Let us talk about cache replacement strategy. Cache replacement strategy is like this. You have a cache, okay, assume that it's a direct map technique. So in direct map technique, and there are 4 cache blocks, and we know that we will have tag field, correct? Here, assume that currently in cache number 0 we have a block called B1, which is nothing but main memory block B1. So now currently processor is referring a memory address, and that memory address belongs to a main memory block called B5, say like this, okay, B5. Now B5, if I apply the direct map technique, then B5 should go to this cache block 0. Such a way this B5 exists, okay. Then what we do, already B1 is occupying that block, right, cache block. We know one thing, only one block we can keep in one particular cache block, right? So what to do then either you keep B1 and don't update B5, because according to direct mapping technique B5 should go here only, but if you don't remove B1 you can't keep B5, and we never keep B5 in the other blocks, right? So searching will be difficult, we know that, right? The main important idea about direct map technique is reducing the that hardware, right? And to get the faster access. So we never keep B5 here. Then what to do? Sir, don't update it, keep B1 here. Then you are not taking the new data, then you are losing one idea. What is that? Temporal locality. Whenever a user refers a block, then there is a high chance that he is going to refer that block again and again. Then if you don't update it, then you will be losing these two things. One is, what is that? Temporal locality and spatial locality. That means you are not following this temporal locality and spatial locality, then you don't get a right thing. That means your cache will get lot of misses. To avoid that, immediately whenever a user refers a new block which is not part of the cache, we should replace B1 and we keep B5. That is what the idea. Okay, so this algorithm is called least recently used block removal. Understand? So finally, the removal of the block, which block we have to choose, depends on this algorithm called least recently used. Okay, so least recently used block will be removed. That's it, remember it. Okay, so you don't understand for one direct map technique, but if it is associative mapping you can easily understand. Currently, let's say, did you remember associative mapping? In associative mapping, any block can go anywhere, any main memory block can go anywhere, so that it will give the flexibility for the blocks, right? B1, B2, B3, B4, let's say current blocks. Suddenly, let's say B5 wants to fit here, because user referred B5, we have to keep there. We want to update the cache. Then what to do? Then in associative mapping technique, rather than fixing one particular thing, anything we can remove. Then this strategy really applicable. What is that? Least recently used block. Somehow your hardware should count it. Okay, so let's say your hardware has an idea that B1 is least recently used, then that will be replaced. Understand? For that we need extra hardware. So using the hardware, we implement least recently used technique. Okay, let's say we keep B5. Later, suddenly user, let's say, referred a memory block called B6 because of the memory address. So let's say user referred one main memory address that is nothing but a block number B6 which is not available here. But currently, let's say B4 is least recently used, then that will be replaced. In that way, so LRU algorithm will work. Understand? Least recently used block will be removed. Okay, not it will be hold. Okay. So using that, now we will try to solve this problem. That's it. Very simple concept. We'll try to apply so that we'll remember it. Assume there are 3 small caches, each consisting of 4 one-word blocks. Understand? So the question is about a small cache with 4 blocks, right? Then one cache is fully associative. That means we have to take 3 models. The first model is fully associative. Second model is two-way set associative. Third one is direct mapped. Understand? Now 0, 8, 0, 6, 8 are the main memory blocks a processor referred. Okay, so directly, sir, do we have any instruction to refer a main memory block directly? No, we just refer a main memory address, but that address belongs to one of the block. Whenever we refer a main memory address, we say that we referred a main memory block. Okay, let's say these are the following main memory blocks 08068. Then how cache will be updated using LRU algorithm? We will see. First of all, we start with fully associative mapping. In fully associative mapping, so let's say these are the cache blocks 0, 1, 2, 3. Assume that we whenever we have a conflict, otherwise whenever we have choice, always we fill least number. Okay, such a way let's say circuit is fixed. Okay, it's not compulsory, but we can assume like that. Okay, not a problem. So first of all, whenever user refers 0, since cache is empty, then you get a cache miss, right? I am also counting the number of cache misses. In the model of fully associative, number of cache misses are first miss for 0, correct? 1. Let me count it. 1. Let me put here star. That means cache miss. Then 8. So here I already kept 0. Now cache block, main memory block 8. It is fully associative. In fully associative, any block can go anywhere. So we have a place here, we keep here. Such a way I have a circuit. Understand? So don't ask me, sir, why don't you keep here? My circuit is very simple. It will try first least number, after that highest number, in that way. So then 8. Then again it's a miss, right? Then 0. This time it will hit, right? So there is no problem. We access the data, right? So hit, I can say. How many misses we have so far? 2. Then 6. It is not available. Then keep here. Then again it is a miss. Then after that 8, because it is already there. Then it is hit. In that way, when you refer 08068, then how many misses occurred? 1, 2, 3. So 3 misses we got, right? 1 for 0, 1 for 8, 1 for 6. Understand? And minimum will be 3, because these are the 3 different blocks. So initially your cache is empty, then definitely misses will occur, right? So minimum is 3, and fully associative mapping also gave 3, right? So this is about fully associative mapping. Now let us take second one, two-way set associative mapping. Okay, in two-way set associative mapping, we will be having 2 sets, isn't it? So this is set 0, this is set 1. Understand? Now two-way set associative mapping. Now let us try to map these things. First of all, 0, right? So you should know, because it is now not fully associative, then there is a particular place 0 will go, right? How to find out that? It's very easy. So divide your main memory block number 0 by number of sets. How many sets we have? 2. Then you get a reminder. That reminder is going to be the destination. So 0 by 2, reminder is 0. That means this cache is going to, sorry, this main memory block is going to set 0. Okay. So finally, what is the formula for finding the right set? The set number, if you want to find out, the formula is main memory block number percentile, okay, modulo number of sets. Okay, right. So using that, your hardware can find out. Understand? But of course, this percentile operator for us, okay, so your hardware has a special idea, right? It will simply take the right bits. We have seen that also, right? Now 0 percentile, number of sets are 2, then that will give you the set number 0. But in set number 0 we have 2 positions. Whenever there are 2 positions, always I fill the least number. Okay, so that's why 0 will be here. Now number of misses, if I count, then that will be 1 so far. Next 8. So 8 percentile, first of all it's a miss, right? Yes. Then we will go to, first of all, to search itself we have to find out which block, which set we have to search. That's why 8 percentile 2, again reminder 0, but we have a space now. In this set we have 2 spaces, right? So now we can keep 8 here. Then we don't really require to replace, right? So that is the difference. Now I can say that number of misses, of course, again 2, right? Because 0 is a different block, new block and new block. Now 0. Now if you see 0, then 0 is already available, correct? Then do we require to replace anything? No. So I can say that miss, hit 6. 6 is a new one, right? So again it will be missing. So where we have to keep it? To find out that formula is main memory block number 6 percentile number of sets. How many sets we have? 2. 6 percentile to 0. Then 6 wants to come here. but we have now 0 and 8. Which one is least recently used? See the data, you can easily find out, right? So 0, 8, 0, after that 6. That means 0 is not least recently used. It is most recently used. 8 is least recently used. Then we remove this 8 and we keep here 6. Correct? So how many misses so far? 3. After that, unfortunately, 8 came. Because of 8, what happens? We'll apply the same formula. We know that 8 percentile 2 is 0. Then 8 also wants to come to same set, but that set is already occupied. So that is where fully associative mapping gets advantage, because it can utilize anything. But what's the problem with full associative mapping? In full associative mapping, so lot of comparators required, correct? So there is a lot of delay. It's not so easy. So remember, because of that, hit time will be increased. To hit the cache, it takes lot of time in associative mapping. So in set associative mapping, now another miss, but which one is least recently used? 0 or 6? 0, correct? So 0 will be replaced in that way. So finally, the number of misses are 4. In associative mapping, number of misses are 3. Okay, 3, now 4. The last concept is direct mapped. In direct mapped, everything is a set, right? There are 4 sets, 1, 2, 3, 4. Okay, now let us begin again. 0, 8, 0, 6, 8, correct? Let's begin. 0. In direct map technique, the formula is, if you want to know the cache block number equal to main memory block number. Okay, so I write like this: main memory block number by number of cache blocks. That is the difference between set associative and direct map. In set associative mapping, the division here, this percentile, this modulo, we use main memory block numbers modulo number of cache blocks for direct mapping. For set associative mapping, number of sets, that's the difference. So here I can say that number of blocks we have to use. And already I told you one thing, this direct map technique can be imagined as one-way set associative mapping. In one-way set associative mapping, then each set contains only one block, then the number of sets equal to number of blocks. That's why same formula like set associative mapping you can use, but number of sets are number of blocks. So main memory block number 0 percentile. So what is that? Number of blocks. How many blocks we have? Number of blocks totally. So number of main memory blocks, number of cache blocks, 1, 2, 3, 4. So 0 percentile 4, 0. So that means what? 0 will be kept here, right? Because the formula gave us 0. Next, 8. Now let me count it. Number of misses are 1. Then 8. Where 8 will go? 8 percentile, number of blocks 4, 8 percentile 4, 0. 8 also wants to come here. Unfortunately, 0 is already present. We have to replace because 0 is least recently used. Then remove 0 and keep 8. So here we are using LRU algorithm, right, to understand. Number of misses are 2. Then 0. Then again, because of this 0, again it wants to go here only because its formula matches cache block number 0, right? Then we will keep here 0 and we replace 8 because 8 is least recently used. The number of misses are again 1, right? So number of misses overall is 3. Now 6 comes. 6 percentile, number of cache blocks. This time number of cache blocks are 1, 2, 3, 4, right? So 6 percentile 4 is nothing but 2. Remainder is 2. So remainder 2 means, so where 6 will go? Here, right? So it's a miss again. So there are 4 misses so far. 0 miss, 8 miss, 0 miss, 6 here. Then 8. So for 8, formula is what? 8 percentile 4. 8 percentile 4 is what? 0. 8 also wants to come here. There is a lot of space here. Associative mapping can use it, but direct map technique cannot use. 8 should be kept here itself. For that we have to remove 0, right? Least recently used. Understand? Don't say that 6 is least recently used, because in direct map technique, always that 8 should go to, first of all, a particular block, right? Now here, only in associative mapping and set associative mapping you have a choice. You can keep in between some of the blocks. We can choose among some blocks where LRU comes. Understand? Now Here also I can apply the same thing. I can say like this, 8 percentile 4 is what? First of all, formula is important. There is no choice. 8 percentile 4 is what? 0. That means definitely 8 should go to first here. Understand? Here there is only one block. If you have multiple blocks, you can take a choice. Understand? So that's why here definitely 8 will come here. Then that 0 will be replaced. So finally 5 misses. Understand? So direct mapper technique requires lot of misses. That means I can say that among them direct map technique by observation will have less hit ratio. Correct? The hit time will be less. Sorry, hit ratio will be less. That means number of misses will be more in direct map technique generally, and number of misses will be less or least in associative mapping generally. Understand? So this is all about cache replacement strategy and how to apply that cache replacement strategy for different various map techniques.